We have a system of two stars, a binary system, where one star has 5 times the mass of the other, which implies that the center mass has to be 5/6 of the distance from the star of lesser mass to the star of greater mass. Gravitational force between the stars is equal to universal gravitational constant 6.67, I can hardly see the 7, I know you can't, times 10 to the negative 11th Newton meter squared per kilogram squared, multiplied by the product of the masses of the stars. And the product of the masses is 2 times 10 to the 59th kilograms squared. The masses are 2 times 10 to the 29th kilograms and 10 to the 30th kilograms. Approximately the mass of the Sun and 1/5 the mass of the Sun. As you can see by reading the problem, we're given the distance between as 10 to the 8th meters, and that's 10 to the 8th kilometers, and that's 10 to the 11th meters. So that goes in for the radius in the denominator. Of course, we're going to square that. And when we calculate all this out, I think we get something close to 1.3 times 10 to the 27th newtons. Now, if we want to calculate the velocity of an orbit, we set the squared velocity over the radius of the orbit equal to the gravitational force, and we find that the velocity is, well, very simple. We multiply by r1 and take the square root, so we get the square root of r1 times gravitational force divided by the mass. I hesitated because the m1 wasn't in this equation and it's all of a sudden here, but we're setting force equal to force, so we have to multiply the mass of the planet by the centripetal force, v squared over r. Now, in this case, we'd be talking about the first planet, and this r1 here that I haven't explained is the distance of the planet from the center of mass, because the planets orbit their common center of mass. Now, their gravitational force is calculated based on their separation, but their orbital radius, the orbital radius of either planet is its distance from the center of mass. So we calculate the velocity of the first planet in its orbit, and we calculate the orbital velocity of the second planet the same way. If the first planet is the one with the greater mass, then r1 is going to be 1/6 of the distance from the lesser to the greater, 1/6 of the 10 to the 11th meters, or it would be 8.3 repeating times 10 to the, and 8.3 repeating, no, it would be 1.6 repeating times 10 to the 10th meters. 10 to the 10th meters. Okay. Sorry, it's hard to find words some days. And the other would be 8.3 repeating times 10 to the 10th meters. If we're calculating the orbital velocity of the second planet. Of course, we'd use the mass of the planet in each case. Okay, so those calculations are quite straightforward from this point on.